Good morning, children. Yesterday we introduced what is a scalar, what is a vector. Can you tell me what is a scalar? Yes, a quantity has only magnitude is called a scalar. Okay, please tell me what are the examples for scalars? Any of them? Good. Distance, length, mass, etc. Okay, what is a vector? Yes, a quantity has both magnitude and direction is called a vector. Give example for vector. Yes, displacement, force, moment, etc. Okay, today our topic is if A vector and B vector are the vectors represented by two adjacent sides of a regular hexagon, then find the vectors represented by other sides. Here the keyword is hexagon. We know that in 10th standard level. Can you tell me what is equilateral triangle? Equilateral triangle? Yes, all the three sides are equal. Okay. Isosceles triangle? Yes, any two sides are equal. Okay. Can you tell me properties of parallelogram? Yes, in a parallelogram, opposite sides are parallel and equal. Next property for parallelogram? Yes, diagonals bisect each other. Which means, anyone? Yes, midpoint of the diagonal AC is equal to, good, midpoint of the diagonal BD. So which are the properties of parallelogram? But today's topic is hexagon. Remember, what are the properties of hexagon? Okay, first of all, can you tell me what is, how many sides for a hexagon? How many sides for hexagon? Yes, 6 sides for hexagon. Here, let A, B, C, D, E, F be the vertices of the hexagon. And the hexagon has 6 sides. Join all the 6 sides. Now, image it. See, we know that in 9th standard itself, properties of hexagon. Anyone? Yes, very good. AB parallel to DE. Good. Similarly, yes, BC parallel to EF. So, and also, first let us draw the diagram. Now listen, hexagon. To draw the hexagon, we have the technique. First, draw the baseline. First, draw the baseline. Next, in right side 1 point with equal distance, right side 1 point and the left side 1 point. And above, vertically, upwards 1 point and here, vertically, here 1 point. Now, join the edges. Listen. Okay. Which is the hexagon? Now, let us give the name. Let A, B, C, D, E, F be the hexagon. Let A, B, C, D, E, F be the hexagon. Let A, B, C, D, E, F are the vertices of the hexagon. Okay. See, in this diagram, AB, listen, AB is parallel to DE, which is the properties of hexagon. AB parallel to DE. Next, BC parallel to, yes, EF. BC parallel to EF. Also, CD parallel to FA. Okay. Next concept. Say, can you tell me what is AD? Anyone? What is AD? What is AD? Yes. AD is twice of BC. AD is twice of BC. Okay. Can tell me what is CF? Anyone? Yes. CF is twice of AB. So these are the properties. CF is twice of AB. And in this diagram, AB parallel to CF parallel to DE. Similarly, BC parallel to AD parallel to EF. So also DC parallel to FA. Okay. Now let AB vector is equal to, see, given that if A vector and B vector are the vertices represented by two adjacent sides, given data, given information, let A vector and B vector are the vectors represented by two adjacent sides of a regular hexagon. So let A vector is equal to AB vector. That is, let AB vector is equal to A vector. Next, come to B vector. Okay, here let B vector is equal to BC vector. That is, BC vector is equal to B vector. Let AB vector is equal to A vector. Let BC vector is equal to B vector. Two adjacent sides of a regular hexagon given. The question is, find the vectors represented by other sides. That means here totally how many sides? Anyone? Yes, 6 sides. 1, 2, 3, 4, 5, 6. Hexagon contains 6 sides. And the two adjacent sides given. Let AB vector is equal to A vector and BC vector is equal to B vector. Okay, remaining how many sides we have to find? We are asked to find how many sides? Yes, 4 more sides we want to find. They are, we want to find CD vector, DE vector, EF vector and FA vector. So totally 6 sides are there. 2 of the adjacent sides A vector and B vector given, that is AB vector is equal to A vector, BC vector is equal to B vector given. We are asked to find CD vector, DE vector, EF vector, FA vector. Now we want to use properties of regular hexagon. That is important. Here AB parallel to CF parallel to DE and BC parallel to AD is parallel to EF. Also here AD is twice of, yes, BC. Okay, similarly CF is good, twice of AB. Okay, now seeing this diagram, let us join AC for our convenience. Let us join AC for our convenience. Okay, now consider the triangle ABC. Okay, in triangle ABC, there is a straight root AC vector. Listen, consider this triangle ABC. Consider ABC. See, AC vector is equal to AB vector, yes, plus BC vector. So in triangle ABC, AC vector is equal to AB vector plus BC vector. That is, AC vector is equal to A vector plus B vector. So AC vector is ready. So AC vector is equal to A vector plus B vector. Okay. Also, here AD vector is, yes, twice of BC. AD vector is twice of BC. So this AD vector is twice of BC. That means BC vector is equal to B vector. So therefore AD vector equal to, yes, 2B vector. Because AD vector is equal to twice of BC vector. One concept. Okay. Similarly, now CF vector is twice of AB vector. Yes. Which means, can you tell me what is CF vector? Here AB vector and the CF vector are opposite in direction. Therefore, CF vector is equal to twice of AB, no problem. But AB vector and CF vector are opposite in direction. Therefore, CF vector is equal to minus 2A vector. Okay. Next. What can you say about AB vector and DE vector? Yes. AB vector is parallel to DE vector and equal in magnitude but opposite in direction. Here AB vector right side, but the DE vector is left side. So therefore, which is minus A vector. See, totally we have 6 sides, in which 2 of the sides given, remaining 4 sides we have to find, in which AB vector and DE vector are opposite in direction, equal in magnitude, therefore it is A vector, it is minus A vector. Okay. Next, comparing BC vector and EF vector. Here, BC vector and EF vector are equal in magnitude but opposite in direction. So that is EF vector. Therefore, EF vector is equal to minus B vector. So minus B vector, one idea. Next we want to find the remaining 2 sides, that they are CD vector and FA vector. To find CD vector, which triangle I want to consider? Anyone? Yes. In triangle ACD. In triangle ACD, there is a straight root AD vector. Okay, now can you tell me AD vector equal to? Yes. AD vector is equal to AC vector plus CD vector. Using this triangle, we can find CD vector. Okay. One idea ready. Next. Now I want to find FA vector. Any idea to find FA vector? Yes. Here, CD vector and FA vector are opposite in direction. Suppose if you know CD vector, then FA vector is opposite in sign, because say CD vector upwards and FA vector downwards, opposite in direction. So CD vector and FA vector are opposite in sign. That's idea. Okay, now come to the theory portion. This is a diagram itself answer, no need to prepare. It is very simple question. Let A, B, C, D, E, F be a regular hexagon. Let A, B, C, D, E, F are the vertices of a regular hexagon. Next we know that we need the properties. Can you tell me what are the properties? Yes. AB vector is parallel to CF vector and AB vector is parallel to DE vector. Next. BC vector is parallel to AD vector is parallel to EF vector. Also, CF vector is twice of AB vector. Next, yes, AD vector is twice of BC vector. These are the properties. Now come to answer. Listen, first point. Let A, B, C, D, E, F are the vertices of a regular hexagon. Let A, B, C, D, E, F are the vertices of a regular hexagon. Vertices of a regular hexagon. Okay. Next, let AB vector is equal to A vector. Let AB vector is equal to A vector. Okay. Next yourself. Yes. Let BC vector is equal to B vector. Let AB vector equal to A vector and BC vector is equal to B vector. Okay. 2 sides given. Remaining 4 sides we have to find. Okay. Now, consider this lower triangle which is in triangle ABC. In triangle ABC. In triangle ABC, anyone? Yes. AC vector is equal to AB vector plus a BC vector. That is a straight route A to C, point to point. Next route is A to B plus a B to C. That's the idea. So in triangle ABC, AC vector is equal to yourself. Yes. AB vector plus yes BC vector. Okay. Next step yourself. Yes. Thank you. AB vector is equal to A vector. Next. Very good. BC vector is equal to B vector. that is AC vector. Yes, we find out AC vector is equal to A vector plus a B vector. What data is ready? Okay. Now, next step please. Good. In triangle ACD. In triangle ACD. In triangle ACD, AD vector is a straight root. A to D. A to D is a straight root. Next way? Yes. A to C plus C to D. So, AC vector is equal to, AD vector is equal to AC vector plus a CD vector. AD vector is equal to AC vector plus CD vector. Okay. Next, hereafter yourself. Okay. What is AC vector? Can you tell me which is equal to? AC vector is equal to which is, already we have the result, AC vector. Where AC vector is equal to? Yes, A vector plus B vector. Okay. Plus CD vector. CD vector we have to find. So write itself. CD vector. Okay. What is AD vector? AD vector? Good. 2B vector. AD vector is equal to 2B vector. Why? Because AD vector is equal to 2B vector. Anyone? Yes. AD vector is twice of BC. So BC vector equal to B vector. Therefore AD vector is equal to twice of B vector. Okay. Now simplification. Let us write in reverse order. That is, reverse it for our convenience. A vector plus B vector plus CD vector, which is equal to 2B vector. Good. Okay. Now I want to make CD vector equal to something. So what is the simplification? Very good. A vector goes to right, becomes negative. Next, B vector goes to right, minus B vector. Okay. CD vector left side itself. Next step yourself. Very good. CD vector equal to 2B vector. Next, A vector goes to right, minus A vector. Next step, yes, B vector goes to right, minus B vector. Now, further simplification, please. Good. 2B vector positive, minus B vector. So 2B vector minus 1B vector, which is equal to, yes, B vector. Okay, next remaining, yes, minus A vector. So CD vector is equal to B vector minus A vector. Yes, we find out CD vector equal to B vector minus A vector. B vector minus A vector. Okay, ready. Listen, two of the sides given and the remaining four sides we have to find, in which CD vector equal to B minus A. Here AB and DE are parallel but opposite in direction, equal in magnitude. Therefore, AB vector is equal to A vector and DE vector equal to minus A vector. Next, here BC and EF are, yes, parallel, opposite in direction, equal in magnitude. Therefore, BC vector equal to plus B vector and EF vector is equal to minus B vector. So 1, 2, 3, 4, 5 ready. Next remaining we want to find a FA vector. Okay, any idea to find FA vector? Yes, here CD vector and FA vector are opposite in direction, equal in magnitude. Opposite in direction, equal in magnitude. Therefore, let us write the reports. Listen. Here, CD vector is parallel to FA vector. CD vector is parallel to FA vector. And in opposite direction. Opposite direction. You see, CD vector and FA vector are equal in magnitude but opposite in direction, and they are parallel. Therefore, here CD vector positive means FA vector is negative. That's idea. Which means FA vector is equal to negative of CD vector. Negative of, because we want to sign change, opposite in direction. Therefore, FA vector is equal to minus of CD vector. Okay, which is equal to minus of, what is CD vector? Yes, CD vector is equal to B vector minus A vector. CD vector is equal to B vector good minus A vector. Okay, simplification yourself. Yes, minus going to multiply inside. Minus into minus plus A vector. Let us write in first. Next, minus into B vector minus B vector. So which is equal to minus into minus plus A vector. Minus into B vector, yes, minus B vector, which is FA vector. FA vector is ready. And also, let us write, to find a DE vector, let us write the reportion. Here, AB vector and the DE vector are parallel but opposite in direction. See, AB vector is parallel to DE vector. DE vector and opposite in direction. And in opposite in direction. Opposite direction. Therefore, can tell me what is a DE vector? DE vector is equal to, yes, minus A vector. Is equal to minus A vector. Okay. Next. Now, let us write the reportion for EF vector. Anyone? Yes. BC vector is parallel to EF vector. Equal in magnitude but opposite in direction. Here, BC vector, okay, yourself, BC vector is parallel to EF vector. And good. And in opposite direction. Opposite direction. Equal in magnitude, opposite direction, and they are parallel. Therefore, BC vector and BC vector equal to plus B vector. Therefore, EF vector equal to, yes, minus B vector. EF vector is equal to EF vector is equal to minus B vector. Okay. Now count it. All the remaining 4 sides are ready or not. Totally 6 sides, in which two adjacent sides given. Remaining 4 sides we have to find. Okay. Here, first one is CD vector is equal to B minus A. CD vector is equal to B minus A first. Next, FA vector. Listen. FA vector is equal to, yes, already we find out, FA vector is equal to A vector minus B vector. FA vector is equal to A vector minus B vector, because minus A vector opposite, yes, plus A vector, plus B vector opposite, yes, minus B vector, that's all. So FA vector is ready. Second one. Next, we need DE vector. Yes, DE vector is ready, which is third one. See, third side is DE vector. Next, last one, yes, EF vector. EF vector is equal to minus B vector. So all the remaining 4 sides ready. Now let us write conclusion. Anyone? Yes. The other sides of a regular hexagon are, yes, B minus A, comma, minus A vector, comma, minus B vector, comma, A vector minus B vector. Let us write conclusion like this. The remaining 4 sides of a regular hexagon are CD vector is equal to B vector minus A vector. Next, good. DE vector is equal to minus A vector. Next, yes. EF vector is equal to minus B vector. Next, FA vector is equal to, yes, A vector minus B vector. Now result. Okay, result yourself. Yes, the remaining 4 sides. The remaining 4 sides. The remaining 4 sides of a regular hexagon. Of a regular hexagon. Hexagon. Or, okay, yourself? Yes, start from here. That is, CD vector is equal to. Okay, CD vector is equal to, yes, B vector minus A vector. Okay, next. Anyone? Yes. DE vector is equal to. DE vector is equal to, yes, minus A vector. Minus A vector. Next. EF vector is equal to, yes, minus B vector. EF vector is equal to minus B vector. Next. Yes, FA vector. FA vector is equal to, yes, A vector minus B vector. A vector minus B vector. So answer the answer. Children listen. 8.1 first sum. Represent graphically the displacement of 45 centimeter, 30 degree north of east. First subdivision. Come to second subdivision. 80 kilometer, 60 degree south of west. Okay. First, let us rewrite the question for our convenience. Here, 30 degree north of east, which means from east to north, 30 degree. And the distance is 45 centimeter. Distance is 45 centimeter. Let us rewrite the question for our convenience. Listen. 45 centimeter from east to north 30 degree. From east to north 30 degree. So which is the concept? From east to north. So which is idea? Similar idea. Here, let us rewrite the question. 80 kilometer, here 60 degrees south of west, which means from west to south, 60 degree. So from west to south. From west to south, 60 degree. Okay. Now let us draw the graph. Because we want to represent graphically, let us draw the graph. Listen. Y-axis and x-axis. X-axis, y-axis, x dash, y dash. Okay. Now come to the question. Here 30 degree north of east, which means from east to north, 30 degree. Okay. From east to north. And we know that, listen, see, it is my answer sheet. This right side shows east. East. East opposite? Yes. West. Can there be north? Good. Upwards. Upwards north. South. Very good. Downwards south. So it is my answer sheet. Right hand shows east. East opposite. Sorry, south. Here north opposite south. Very good. Listen again. It is my answer sheet. Right side. Right hand shows east. East opposite west. And upwards north. North opposite south. Okay. The question is from east to north 30 degree. Listen. From east to north. From east to north 30 degree. From east to north. So this direction. From east to north 30 degree. Arrow is upward. From east to north from east to north 30 degree, and the magnitude is 45 centimeter. 45 centimeter, that's all. Okay, similarly, come to the second subdivision. Let us draw the graph. Graph, as usual, x-axis, y-axis, yes, very good. X dash, downwards, y dash, okay. And we know that it is my answer sheet, capital B east, very good. Answer sheet, right side, east, east opposite, west, okay, north, very good. North, upwards, north, north opposite, south, okay, south. Now, the question is 60 degree south of west, which means, yes, from west to south, which is the meaning of this question. From west to south. Listen, from west to south, listen, from west to south, from west to south 60 degree, from west to south 60 degree. So which is 60 degree, from west to south 60 degree. And the magnitude is given 80 kilometer, whose magnitude is 80 kilometer. So these two questions completed. Come to next question. Second question from 8.1 exercise, page number 59. Prove that the relation capital R defined on the set V of all vectors by A vector is related to B vector if A vector is equal to B vector is an equivalence relation on V. We want to prove that. Listen again. Prove that the relation capital R defined on the set V of all vectors by A vector is related to B vector if A vector is equal to B vector is an equivalence relation on V. Listen, this question is a concept from second chapter, relation. To learn this sum, we need a basic. Listen the basic. See, first one. First one is, see for example, A is related to A. A is related to A, for example. A is related to A, where this capital R denotes a relation. See for example, Ramu is a son of Gopal, which is a relation. And for example, 7 is greater than 4, likewise. 7, listen, 7 is greater than 4. Here, greater than is the relation, that's all. Greater than is the relation. See for example, 2 is less than 7. 2 is less than 7, where less than is the relation. So this topic comes relation, and to learn this sum first we need basic. Okay. Listen, first one, A is related to A. If A is related to A, where a capital R denotes a relation, A is related to A means A itself relation. And if A is related to A, therefore A is that is capital R is reflexive. Capital R is reflexive. If A is related to A, then the relation R is reflexive. First one. Okay, come to second one. Second one is A is related to B. Suppose A is related to B, which implies B is related to A. B is related to A. Therefore, R is symmetric. Therefore, the relation R is symmetric. Second one. Come to third one. Third one is A is related to B and A is related to B and B is related to C, which implies, listen, A is related to B and B is related to C, which implies here the center BB cancel. Center BB cancel. Let us take first and last. First and last means A is related to C. A is related to C. Therefore, R is transitive. R is transitive, that's all. And a relation which satisfies all the three properties then the relation R is said to be equivalence relation. That's the idea. Again listen, A is related to A, itself relation. A is related to A, then R is reflexive. Next property, A is related to B and B is related to A. That is, A is related to B, which implies B is related to A. Therefore, R is symmetric. Next, the third one, A is related to B and B is related to C, which implies here the center BB cancel, consider first and last, which implies A is related to C. A is related to C, therefore R is transitive. Therefore, a relation R which satisfies all these three properties, that is reflexive, symmetric, transitive, then the relation R is said to be equivalence relation. So, which is the basic for this question. Now come to our question. First of all, given that, given, what is given? A vector is related to B vector if A vector is equal to B vector, is an equivalence relation on the set V, where V is the set of all vectors which is a non-empty set. Okay, let us read this concept in reverse. If is a condition, if is a conditional class, if you study well, then you will be passed like that. Where if is a conditional class. If A vector and B vector are equal, then A vector is related to B vector. So A vector and B vector are equal, then A vector is related to B vector, where this equal is a relation. That's all. Here this equal is said to be the relation. Ramu is a son of Gopal, and 2 is greater than 7, and 4 is less than 2, likewise, which are the relation. Okay, given information is, if A vector is equal to B vector, implies A vector is related to B vector. That is, let us write the condition given. If A vector is equal to B vector, then A vector is related to, yes, B vector. If A vector equal to B vector, then A vector is related to B vector. Is a condition is given. Now come to first subdivision 1. Subdivision 1 is, anyone? Yes, reflexive. Good. First topic is reflexive. Okay. Can you tell me definition of reflexive? Anyone? Yes. Itself means reflexive. Here, A vector is equal to A vector. Yes, we know that A vector and A vector are equal. Whether it is true or false? Yes, true. A vector equal to A vector. Yes, which is true. A vector equal to A vector. Which implies, if A vector and A vector are equal, then we can say A vector is related to A vector. A vector is related to A vector. That's all. A vector and A vector are equal, where equal is the relation, where equal, which means the relation. That is, relation is equal. Okay. Therefore, the relation R is, yes, reflexive. Therefore, the relation R is reflexive. Okay. First subdivision is completed. Come to second subdivision. Anyone? Yes. Symmetric. Symmetric. Okay. Symmetric, remember the definition? Yes. A is related to B, which implies, yes, B is related to A. Therefore, R is symmetric. Listen, here, A vector is equal to B vector. A vector and B vector are equal, which implies A vector and B vector are equal. Conversely, yes, B vector equal to A vector. B vector is equal to A vector. Yes, correct. A vector equal to B vector. Therefore, B vector equal to A vector. Where equal is the relation. Therefore, A vector is related to B vector, which implies B vector is related to A vector, where equal is the relation. That's all. Therefore, A vector is related to B vector. Next step, very good. Which implies B vector is related to A vector. B vector is related to A vector. Therefore, what can we say about the relation R? Yes, the relation R is symmetric. Therefore, the relation R is symmetric. R is symmetric. Therefore, the relation R is symmetric. Okay. Can you tell me third topic? Good. Transitive. Third topic, transitive. Third topic is transitive. Transitive. Okay. Definition for transitive. Yes. A is related to B and yes, B is related to C. Implies? Good. Center and center. BB cancel. First and last. Yes. A is related to C. Now listen. From the definition, here equal is the relation given information. So A vector is equal to B vector and yes, B vector is equal to C vector, which implies yes, here the center BB cancel. Very good. Take first and last. A vector is equal to C vector. A vector is equal to C vector. Okay. Where equal is the relation. Wherever equal, which is a relation. Instead of equal, we can write relation. Now, therefore, okay, here after yourself. Yes, thank you. A vector is related to B vector. Yes, and yes, B vector is related to C vector, which implies good. A vector is related to C vector. Okay. Here, the non-empty set, the set of all vectors satisfies yes all the three properties. So here the relation R is reflexive, the relation R is symmetric, the relation R is transitive. Here third one is the relation R is transitive. The relation R is transitive. The relation R is transitive. From 1, 2, 3, the relation R is an equivalence relation on the set of all vectors. So from 1, 2, 3. From 1, 2, 3, the relation R is equivalence relation. The relation R is equivalence relation. Equivalence, that's all. Children listen, fourth question from first exercise. If D and E are the midpoints of the sides AB and AC of a triangle ABC, prove that BE vector plus BC vector is equal to 3 by 2 into BC vector. Okay, listen first, keyword, here triangle ABC. So, let us draw the triangle ABC first. Listen, in triangle ABC. In triangle ABC. In triangle ABC, D and E are the midpoints of the sides AB and AC respectively. Here, D is the midpoint of, yes, AB. E is the midpoint of, yes, AC. D is the midpoint of AB. Listen, D is the midpoint of AB. Next, E is the midpoint of AC. E is the midpoint of AC. Now, join DE. Okay, one can join DE, no problem. Okay, now let O be the origin of vectors. Let O be the origin of vectors. Origin is anywhere. That is, O is the point of intersection of x-axis and y-axis. The origin is anywhere. Let ABC be a triangle given. Let D and E be the midpoints of the sides AB and AC respectively. So join DE, where D is the midpoint, where MP denotes midpoint. MP means midpoint. Okay, E is midpoint of AC. Yes, midpoint of AC. Next, let O be the origin. Then we know that the position vector of A with respect to origin O, that is OA vector is equal to A vector. Similarly, yes, the position vector of B with respect to origin O is B vector. That is OB vector is equal to B vector. OA vector is equal to A vector. Okay, next yourself. Good. The position vector of C with respect to origin O is C vector. Okay, which means OA vector is equal to A vector, OB vector equal to, good, B vector, OC vector is equal to, yes, C vector. Okay, now come to the keyword midpoint. Can you tell me D is a point of, that is the position vector of D with respect to origin O is midpoint formula. Good. Here D is the midpoint of AB, therefore OD vector is equal to A vector plus B vector by 2. A vector plus B vector by 2. Okay. The position vector of E with respect to origin O is, yes, OE vector. OE vector is equal to, very good, because midpoint, your answer is correct. So OE vector is equal to A vector plus C vector by 2. Good. A vector plus C vector by 2. Okay, listen from the diagram. OA vector is equal to A vector, OB vector is equal to B vector, OC vector equal to C vector, OD vector is equal to A vector plus B vector by 2, OE vector is equal to A vector plus C vector by 2. Okay, initial preparation ready. Here first of all, given in triangle ABC, D and E are the midpoints of the sides AB and AC respectively, which is given information. Let us write given. Given D and E are the midpoints D and E are the midpoints of the sides, yes, AB and AC, full stop, which is given information. Okay, now to prove. What we are asked to prove? Yes, from the question, we want to prove BE vector plus DC vector is equal to 3 by 2 into BC vector. Let us write to prove BE vector plus DC vector is equal to 3 by 2 into BC vector. Okay. Now, listen. We want to prove sum of two vectors is equal to 3 by 2 of BC vector. Okay. To prove this result, first let us find BE vector, first equation. Then let us find DC vector, second equation. Then after I want to adding 1 and 2 or subtracting 1 and 2? Yes. Adding 1 and 2, we are going to get the required answer. Okay. Now, let O be the origin. And the position vectors of A, B, C are small a vector, comma small b vector, comma small c vector. And the position vectors of D and E, that is OD vector is equal to a vector plus b vector by 2, and OE vector is equal to a vector plus c vector by 2. Okay, now let O be the origin. Let O be the origin. Okay, let O be the origin. Let the position vectors of A, B, C are A vector, good, B vector, yes, comma C vector, respectively. Let the position vectors of capital A, capital B, capital C or capital A, capital B, capital C or small a vector, small b vector, small c vector, respectively. Good. Which means, can tell me what is which is written in the sentence form? Can tell me equation form? Yes. OA vector is equal to a vector. Therefore, OA vector is equal to a vector. Next yourself. Yes. OB vector is equal to B vector. Next. Yes. OC vector is equal to C vector. Okay. Next. What can we say about D and E? Yes, they are the midpoints. We know that the midpoint formula. Can tell me OD vector is equal to? Anyone? Yes. OD vector is equal to A vector plus B vector by 2. A vector plus B vector by 2. Next. Yes. OE vector. OE vector is equal to? Yes. A vector plus C vector by 2. A vector plus C vector by 2. Okay. Now, we want to prove sum of these two vectors is equal to 3 by 2 of BC vector. Now let us find B vector be the first equation. Then DC vector be the second equation. Adding 1 and 2, we are going to get a required result. Okay, come to first term. Listen, first term B vector. Okay, B vector is equal to. Here, B vector is equal to, because O is the origin, B vector equal to second minus first. Second minus first means OE vector minus OB vector. That's all. Consider first term B vector. Take B vector. B vector is equal to second minus first. That is OE vector minus OB vector. Okay, hereafter yourself. Which is equal to? Yes. OE vector is equal to A vector plus C vector by 2. So OE vector is equal to A vector plus C vector by 2. Bracket minus OB vector equal to? Yes. B vector. So minus B vector. Whose left hand side is B vector. Okay, box it. Which is a first equation. First equation written. Now, yes, very good. Second term, DC vector. DC vector equal to? Yes, same idea. Second minus first. That is OC vector minus OD vector. Okay, here after yourself. Yes, OC vector equal to C vector. C vector minus of OD vector. Yes, OD vector is equal to A vector plus B vector by 2. A vector plus B vector by 2. Which is? Yes, DC vector. Box it. Which is the second equation. Now, good. Adding 1 and 2. Now, adding 1 and 2. 1 plus 2. Adding 1 and 2. Is yourself? Sum of left hand sides. Good. Sum of left hand sides. B vector plus DC vector. which is equal to, yes, sum of RHS, that is A vector plus C vector by 2 minus B vector. Next, good, second equation, plus C vector minus, good, minus of A vector plus B vector by 2. Okay. Further simplification. Good. LCM 2. Okay. Very, very good. That is LCM 2. Consider the LCM 2 under the first denominator. Yes, 1, 2 is 2. So 1 into numerator. Very good. A vector plus C vector. Next. Come to second term. Yes. Divided by 1 understood. Very good. So 1, 2 is 2. That is minus 2B vector. Next step. Yes. Denominator by 1 understood. But LCM is 2. Therefore 2 into C vector plus 2C vector. Next is denominator 2. LCM 2. 1, 2 is 2. So 1 is multiplied with the numerator. 1 into A plus B equal to A plus B. But anyone? Yes. Very good. Minus going to multiply inside. Minus into A vector minus A vector. Next. Good. Minus into plus minus B vector. Now which is equal to simplification yourself. Suppose by 2. Yourself. Any cancellation please? Good. Very good. Plus A vector minus A vector. Next. Any cancellation? Very good. No cancellation. Because plus C vector plus 2C vector. So plus 3C vector. Next. Good. Minus 2B vector minus 1B vector. Totally minus 3B vector. So write positive term first. Which is positive? Yes, C vector is positive. 3C vector. Yes, minus 3B vector. Okay. Now which is equal to? Children listen. Any further simplification? Yes. From numerator, 3 common. And by 2. So we can taking out 3 by 2. So which is equal to 3 by 2 of. Next step, good. C vector minus B vector. C vector minus B vector. Okay. Which is equal to 3 by 2 into. Can you tell me what is C vector? Yes. C vector is equal to OC vector. Thank you. C vector is equal to OC vector minus. What is B vector? Yes. B vector is equal to OB vector. OB vector. OB vector. Okay. Which is equal to OC vector minus OB vector. Is of the form? Yes. Good. Second minus first. Second minus first. Because already we have BE vector is equal to second minus first. OE minus OB. Similarly, DC vector is equal to second minus first. OC minus OD. Likewise, OC minus OB means good, second minus first. That means B first and C second, which is equal to 3 by 2 into BC vector. 3 by 2 into BC vector. So consider, come to the conclusion, 3 by 2 into BC vector. Yes, we received the answer. What is LHS? Right now question with answer. Therefore, BE vector plus DC vector is equal to 3 by 2 into BC vector. So answer the result.